Practice drawing Lewis diagrams. Let's practice with iodine, or molecular iodine, or diiodine. We'll just call it iodine here. It's a diatomic molecule, and it's typically found the two iodines bonded together. So the first step is, what's the total amount of valence electrons? Iodine is in group 17, so each iodine has 7 valence electrons. There are 2 of them, so we have a total of 14. Step 2. You put the atom with the lowest electronegativity in the middle, but since they're both the same, we're going to go ahead and put them side by side. So look at this. See how we do that? Drag and drop the required elements, bonds, and electrons from these boxes, or you can draw them in your notes, and when we're done, we're going to check the answer tab to see how we did. So let's pull another iodine down here. Okay. Step 3, connect them with the single bond. So let's just move him a little closer there, and let's grab a bond and put the bond there between the 2 iodines. Step 4, count each bond as 2. So we have 1 bond, so we've accounted for 2 electrons. Now, fill in the outer shells so that we have complete shells to get 8, the octet. So we take this guy here, so 1, this probably won't be the neatest thing in the world, but we'll do our best. 2, 3, 4, 5, whoops, gotta get right on the dot, 5, 6, so 2, 4, 6, and let's just imagine I did the same thing on the other iodine. So each one of them has 8. Now do the same for the central atom. Well, there is no central atom in this case. And do we have full outer shells? Well, let's look at this guy on the right. There's 2, 4, 6, and in the bond counts as 2 electrons, so that's 8. And then, can you imagine we did the same thing on the other side, and we'll get 2, 4, 6, 6 plus 8 is 14, and we've already accounted for these 2 electrons when we counted the iodine atom over there. So let's see if that works out. And yep, that's what we have. Again, I didn't draw the iodine on the left, but you can see here it is. Now let's practice with chlorine, molecular chlorine. It's in the same group as iodine, so it has 7 valence electrons. So we're going to have a total of 14. That's our first step, 14 valence electrons. Again, it's the same molecule, same atom, excuse me, so we're just going to pull one so you don't have a center and external ones. So you start by bringing the 2 chlorines down. You grab one bond to connect them. And let's move this chlorine down a little bit. Next, count each bond as 2. So we only have 1 bond there, so we have 2 electrons taken care of already. And the next thing we want to do is fill the outer shells. So we're going to take this electron here, 1, 2, 3, 4. Try and even these guys out a little bit. It's probably easier to draw this in your notebook. 2 and 2. And again, I'm not going to do the guy on the left. We'll just assume it's a mirror image. And let's count them up. 2, 4, 6, then 8 for the bond here, so we're up to 8. And just imagine you can see 2 here, 4, 6, 8 plus 16, 14. That's the correct amount of valence electrons. And remember, only count this guy once as 2 electrons. They're sharing those electrons. So let's see if the picture is the same as ours. Yes, it is, with the exception, of course, I didn't draw the one on the left side, claimed it was a mirror image, and we're good. Carbon tetrahydride, or methane. The first step is to find the total amount of valence electrons. Carbon has 4, hydrogen has 1, and since we have 4 hydrogens, 4 times 1 is 4. We have a total of 8 valence electrons. We don't even have to look up who has the lowest electronegativity because hydrogen can never be the center atom. So that has to be carbon. So we pull carbon down here, and then we bring our 4 hydrogens and we connect each one of them with a single bond, which represents 2 electrons. So where's our other one? And we take our single bonds. There's one. Here's the other. Probably should move hydrogen up a little bit there. Can't seem to grab that horizontal one there. Here we go. You know what? I'm just going to draw our own little bond in there. Okay, so now let's check. We have to fill in the outer shells to get octets. Well, not octets in this case because it's hydrogen. Carbon will have an octet, but hydrogen, the most it can have are 2 electrons. You count each bond as 2. So 2, 4, 6, 8. Wow, it looks like we're done already. There's our 8 electrons. And each hydrogen has a full shell, and so does carbon. Carbon has 2, 4, 6, 8. So we're good.